So I am a bit new to this recording thing, so I just recorded the entire video and saw that it was paused. So let's confirm. Okay, so it's recording. So this is day 3 of NeetCode 150. We are going to do two sum. So I opened the question here. Let's just erase the solution for now. So okay. So the question is given an integer of given an array of integer nums and there is also an integer target. We have to return index of like indices of the two numbers that add up to the target. So the normal thing in twosome is like there are a lot of variations. So there is also thing where we have to find if there are two numbers that add up to target and return a boolean that is true or false. So we have to here give the indices in a vector of int format, and it is already given that there is exactly one solution. So there is no situation where it gives like -1, like it doesn't have any valid pair. And the thing is, we cannot use the same element twice. Okay, so uh, we just start with the question. So the follow-up is, can you come with algorithm in less than open square? It is also so the first question of LeetCode. Okay, so let's start quickly. So I think like everyone would have understood the question, but let me explain it again. Nums is nums is like, let's take an example 2, 5, 4, 7, 9, 7, 10. This was the example I was using already, and target is 13. So I think uh, we need to find any two elements that add up to 13 in this test case. So the only valid answer is 9, 14 that add up to 13. Let's just give in them index quickly. So in this case, we have to return 2, 3. Now this can be in any order like 2, 3 or 3, 2. Like it doesn't need to be sorted. So let's start. So the brute force approach or the naive approach is try to just make two for loops. So one will go from I to 0 to less than n minus 1 and increment in each step, and then another loop in that is j, that is from I plus 1 to less than n plus plus j. And we just need to find if I nums of I plus nums of j is equal to target. If yes, return ij. So I don't think like I need to write, but let's say nums, let's just say nums is equal to maybe something shorter like AR. So nums of I plus, let's just do nums, it will become confusing. So is equal to target. Then return, and we have to return in a vector of int format. So we need to do like this return, and this is a vector format. So return I j. I think that's clear. And just close the loop. So there's nothing to do. Like we are guaranteed an answer. So let's just dry code this, dry run this. So as you might see, like in this approach, I will start from 2, j will go in this range. Then I will increment, j will go from this to this, and similarly 4 for this, 9 this, and 7, and finally this. So if you want to do it like this. So for 2, the target is 13 and the number is 12. For 2, the needed is, let's say, element, and needed is 13 minus 2. So need 2 needs 11 to make the target 13. So J tries to find 11 in this whole array. So it doesn't find anything. Then I increments. The element is 5. It needs uh, what I think, 8 to make the sum 13, but it doesn't find 8 in any of this. So I increments. Now the element is 4. It needs 9 to make 13. It starts and then finds the 9 in this index. So we return just I and j. So I was 2 and j is 3. So 2, 3 is valid answer. But as you might notice, this is like a brute force approach, naive approach, which contains two for loops, and thus it is an n-square method. So we try to go improve from this to a better method. So let's just not waste any time. And so, okay, so we just take this array. Now another thing you can do is sort them and use a two pointer approach. So as you might see, this is not sorted. So first, uh, you have to think while sorting is that this is an index, this has an index based answer. So you just can't normally sort it, because if the, let's say, index is 0, 1, 2, and if you sort just these three numbers, it becomes 2, 4, 5, but the index is lost. So we need to keep the track of index in this. So we try to declare a vector of pair of intent. So this helps to keep the track of what was the indices of the value. So for 2, we'll keep the value 2 here and index as 0 for this element. For 5, it's 5, 1, 4 is 4, 2. So we just push all these elements into such an vector, let's say array, ARR, and just sort this vector. So it finally becomes something like this: 2, 4, 5, 7, 9, 10, I think. And all index are there, but we will not just write it for now. Then start a left pointer with the first element and right pointer with last element. And remember the target is 13. So what we are going to do is left plus right pointer. So 2 plus 10 is 12. So we write two conditions. Like there are three conditions actually. If the left and right sum is equal to target, then just return L and R. Like not L and R, the index of the L and R stored in that pair. So if they are equal, then just return. Else if sum is, if in this case it is 12, sum is less than target, 12 is less than 13, sum is less than target, move left pointer a bit to the right. So what happens if left moves to the right as it is sorted, the overall sum will also increase a bit. So it's the only approach you can increase the sum, because if you move this left, it will always decrease. So, and else, there should have been if and else, that means sum would be greater than target. So let's see what would we do then. So now it is L, like 12 was less than target. So now this is, but 10 plus 4, now sum is 14. 14 is greater than target. So what we do now? What we will do is move the right pointer a bit to the left. So the sum will increase by some points. There is no other way to decrease the sum. Like even if you want to go backward, that would be just backtracking, and like it would just going backward. There is no point of doing that because it's already seen. So we move right pointer a bit to the left, like one step to decrement. So our minus minus is the thing here. If sum is greater than target, so 9 would come here. So 9 plus 4, 13. 13 is equal to target. So we just return the indices stored in that pair. So this approach, as you see, the sorting method is in log n, O of n log n. And the two pointer might take at first O of n, but overall it's O of n log n. But what if I told you like there was also more efficient way? So one last way, like the best way of doing this is using an unordered map. So let's just take this down here. Okay. So what we are going to do is creating an unordered map. If you don't know about unordered map, it's like a dictionary in Python. You store the values in key value pairs elements. So this is like a pair you store in key value pairs. So unordered map, you need to define two data types like int because value will be int and index is also in it. And then you just start iterating through first. Let's just try and follow me through the loop, and you'll understand what I'm saying. Sorry. Uh, this is just a normal for loop that goes from I equals to 0, I less than n plus plus I. So now what we'll do is check. First of all, this is not sorted, right? Okay. So first element is 2. Then we just need to create this again. So first element was 2. To create the sum as 13, we need 11. So we check if 11 was there in map or not. So I hope this much is visible. So let's say this is map MP and we'll store all key value pairs. So first of all, check like calculate the need, that is target minus element, and check if MP dot find need is there. If it's there, just return the value of that and this current index I. If not, then we just move to next step, that is insert in the map the current value and its index. We dot insert the nums of I and I, which is its index. So 11 was not in the map, so we just insert 2 with its index 0. So this is a key value pair in now our map. Then 5. For 5 we need 8, but it's not there. So we just add 5, 1, 4. For 4 we need 9, but 9 is not there in the map. So we add 4 with its index 2. And finally 9. For 9 we need 4. But as you see, 4 is already in the map. So we return this because this was the index of 4 and the current I, which is the index of 9, which is 3. So we return 2 and 3. So it's a best way. So like it just look for the corresponding needed element. If it's not there, it just adds them. So as you know, an ordered map does the lookup in O of n, so it's more efficient than any other method. So let's just code it up quickly. So this is an ordered map of int int, let's say MP, then start a for loop to nums dot size, and then calculate the needed element. So needed is target minus nums of I if nums, sorry, if mp dot find need is not equal to mp dot end. That means the element is there. Mp dot end, that mp dot find will return mp dot end only when the element is not in this map. Now this not equals to me that this needed target needed element is there in the map. So we just return, this is the format for of n, return mp of need and the current index I. Else we just insert the element in mp, which is nums of I and I. Now we need to return need to give a return command at the end so that the code doesn't give an error, but it will always return the value from here because we have been guaranteed an answer. So let's run. Now this works. Mm. So this is also like 0ms. But if we wanted to the solution to that approach of sorting, so I can also show you that. I did it a while ago. Wait a minute. Okay, so this was the sorting approach. Like we sort and create the left and right pointer, which is I and C here, and just increment and decrement left and right pointer as we need. This I needed a return of min max because I was confused between like returning the vector of int in sorted way. So this gives it in sorted way, but you can just do other method. Like you don't need to check min max. And that also gave me O of like not O of n, but the zero errors. So okay, that's all.